Are you ready? Okay. Tony, you're up.
Hey, everybody, welcome. Thank you so much for being here. I'm Tony DeHart. I have the pleasure of being the head of operations at Blue Sky Robotics, but I also am the child of two small business owners. And so finding ways to solve problems with technology and actually make things easier on small business owners is really near and dear to my heart, which is why I'm so excited to welcome you here to our conference today. We're going to be showing you some of the technology that we've been working on in the lab and are now ready to put to work in your businesses. And with that being said, I'm excited to introduce Stephen King, but instead of having me do the introduction, I thought we'd get a little bit of help from artificial intelligence. So without further ado.
And though he is not a fortune teller, our next speaker will tell us what the future holds, a bridge between technology and humanity. He's at the forefront of reimagining how we experience and interact with the world around us. Our renowned speaker, Stephen King, holds a unique and pivotal position at the University of North Carolina, Chapel Hill, where he blends the boundaries of innovation, computer science, and business. As the Chief Innovations Officer of UNC Blue Sky Innovation, Stephen is not just about discussing the future. He's actively sculpting it by leading the creation of groundbreaking tech. Stephen's expertise is sought after by government agencies and Fortune 500 corporate executives. Join me in welcoming a man who is not just living in the present, but actively crafting the future. Distinguished Professor of Innovation, Stephen King.
Yeah. So AI made you think that you needed to clap, right? So just so you know, that was completely researched and written by ChatGPT. It has a synthetic voice, a synthetic avatar, and all of that was AI generated. So in Winston-Salem in 1937, a very famous company was born. Does anybody know what it was? No. Good guess. But another one, oh, that's how you know it was on the thing. So right next to Haynes was Krispy Kreme. And there were some men who had come together. They had a business plan. They were going to do a distributed model where they made the donuts and they sold them to the grocery stores, and the grocery stores sold them on. Well, things weren't going that great, but they were right next to this factory in this manufacturing district, and they could smell the donuts. They wanted those donuts, and they would come, and he's like, I can't sell them to you. And so the business guy was like, no, we're a distribution model. But the guy who was all about the original idea, he basically came up with the fact that he needed to bust out a wall and make a window and create what would now be Krispy Kreme. Now, he sold them one donut at a time to each one of these people who were working in this manufacturing district. And Krispy Kreme was born. They got their first shop. They ended up actually moving into a home in Winston-Salem to kind of start off there. And they grew very quickly. But one key thing about it is their focus on automation. About 1950, they had invented the first donut maker, the first automated donut maker. Now, they didn't do this because they were trying to save money. They did this because they wanted consistency. They wanted that every single donut that they made at every single location would be exactly the same. So they invented the first donut maker, which you see there on the right. And then that grew and evolved over time, and went to all this way of how much time was spent on it, how it was sugared to get the exact consistency of that icing. And so automation totally built that company. Today, Krispy Kreme sells 1.8 billion donuts annually, all made through automation, and they've continued to grow. So there's a lot of things that we can learn from Krispy Kreme, and we're going to talk a little bit about how much robotics, AI, and automation comes together, and how we do this working together with the humans as well as the machines. So when we say automation, we're going to take a kind of a broad definition here from Michael Hyatt. And Michael Hyatt said that automation means solving a problem once and then putting the solution on autopilot. So we like to think about robotics as this new and up-and-coming thing, but it's obviously been around a long time. And what we try to do is find the simplest way to repeat the process over and over again? How can we do this with the lowest margin of error, the highest quality? How do we do this over and over again? So that's really what we're talking about when we say automation. But all of us think about AI, we think of this utopian world. We think of this world where we have flying cars and self-driving cars and maybe self-flying vehicles of whatever you want to call it by that point. And we dream of this future and we say that AI is going to get us and take us there. While at the same time, our science fiction tells us that we're a little bit afraid of this. We're afraid that AI is going to take our jobs, and maybe one day it's going to become self-aware and take over the world. Well, I don't think that's going to happen, but I think there's a lot of things that we can learn about AI and things that we need to understand. So I want to open the question to you. Do you think that AI is a trend or a fad? Is it something that's going and coming and going to be here, or is it a fad that's coming and going away quickly? What do you think? What do you say? Trend? What do you think? Trend? Natalie? We're not even going to be separate. So it's going to be such a trend that it's over the top. We won't even separate it from our regular lives. I think you may be right. I think we're going to see a lot. I don't know if you saw the last Google AI, the Google I/O conference. You're not as big of a nerd as me and watch these kind of things. So I have a quick summary so you can see what Google is working on right now. Generative AI, generative AI, AI as AI, 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 AI uses AI to bring AI. So obviously AI is the topic of the day. Right? We see so much around AI, and we can't ignore it. Very specifically, most of the time people are talking right now about generative AI, OpenAI, ChatGPT, and these large language models. For a while, this was a trend or something we saw on the fringe that was coming. And then all of a sudden, 2.5 years ago, OpenAI releases this and it totally changes the world. And everybody's starting to talk about it. But there's a lot more to AI than just generative AI. We have machine learning, which has been around since the 1960s. We have deep data analytics, which is essentially what most people want their AI to do, is do predictive modeling. And we've had that type of analytics for a long time. Natural language generation and natural language processing, essentially how Alexa works, or Siri. Okay? And then one of the things that our company does a lot of is computer vision, or AI imagery, which leverages machine learning and reinforcement learning around computer imagery to understand our environment. And then that has also led to one of the things that I can't ignore, which is the deep fakes and how that has impact on our society. When we say deep fakes, we mean taking something that is real and then making something that is not real from it, because you have machine learning and other techniques to do that. So there's a lot of information out there about me, a lot of information out there maybe about you. So let's just see what a very straightforward AI algorithm can tell you about me. So this is Crystal Knows, and Crystal Knows is publicly available. And just by using my LinkedIn data, this is what it came up for. Stephen is a skilled communicator with the ability to distill big ideas down into actions, but probably has a tendency to take on too much responsibility at once. Greg, you've known me a long time. Would you say that this is accurate? Excellent, right? I just left this one. I took the screenshot while I was setting up the profile. It's literally only 16%. All I've done is connected to my LinkedIn at this point. Okay? It did that with publicly available information. But it's not just that. It also tells you things that you can say to, let me just put the real words to it, to manipulate me. Okay? So one of the things it says, it's not a sure thing, but. So imagine you're a PhD student and you come to me and you said, there's this research that does this, and I want to advance that research and continue that on. I'll say, okay, that sounds great. But if you come to me and you say, I have this idea. I have no idea if it's going to work, but I really want to try it. I'm going to say, let's do it together. I know I don't have time, but let's do it anyway, right? And so that algorithm has figured out that that's who I am in my personality. right? So if you want to learn how to manipulate me, this is a really great tool. Also from a sales perspective, and if you want to be able to understand someone before you go into that meeting, this is something that you can do ahead of time. Maybe you want to do this to your teachers. You can get 3 for free, by the way. So just to let you know, you can go do 3 profiles. Yeah, they're counting it up. They're realizing 3 times 5, that's 15. You got most of your teachers there, right? So there are so many companies doing things in AI. They're not just the big ones. You know of the big ones, but there are all these companies, and I call this vendor soup because everyone is trying to get you to take their piece of AI, their piece of AI and understand it and use them and pay them, okay? But which one is the right one? What are you trying to do? What are you trying to build? And so we're going to talk a little bit about that today. And how do we evaluate good AI companies and good value? What's the value proposition for each one of these? So one of the things that we have to do is to know where they're getting their data from. Okay? Why was that data collected? How did they acquire it? Okay? Because a lot of people collect data. How do we know that what was collected was valuable? Was it just input in there because you were trying to get through a form really quickly and you really didn't care and you just made up some data? Is that something I really want my AI to be built off of? Versus something that's been checked and rechecked, that has lots of different inputs coming from different sources, and those things are then correlated. That's the kind of thing we want to do. The other thing I ask is, why did someone collect this data? Because their reason for collecting it might show you what its influences might be or biases in that data based on what they collected. So once you know what the data you have, then you also need to know the algorithms. And every company is going to tell you, sorry, this is our own trade secrets. This is our own proprietary data. We even say the same thing at Blue Sky Robotics. There's stuff we don't want to share, okay? But I'm telling you right now, you need to push for it, right? You need to understand what they're doing. And you can't always get the code level things, but you can understand what they're doing and how they're doing it. Because known inputs equal predictable outputs. So if it is true, if you know what's going in, you should know what's coming out. And it should be a reoccurring thing. So you can build tests, and you can test this over and over again. And soon you'll have an anomaly. You'll look at that anomaly and understand why for that anomaly. You start to do and understand both the data and the algorithm. And then you have to test its insights. Because sometimes the AI might say, buy this company, go this direction, sell this, add that. Maybe that makes sense. Maybe it doesn't. So put a human check in there. Make sure you understand and you test that data to understand it. Okay? And then you have to iterate on it. You have to iterate on it over and over, because the moment you launch a project, you launch the code, it's probably not the level it needs to be, because you just learned something else by launching it. So you make it a little bit better, and you make it a little bit better. Each time is a new iterative approach that makes the concept that much better. So if you're talking to these vendors, you're not looking for a vendor who's going to just give it to you and walk away. You need someone that you're going to have a relationship with, you're going to be engaged with, and make it what you want over time. So let's move to another trend. Robotic assistants. Talk a lot about humanoid robots and things. So my question to you is, do you think the humanoid robot is a trend, or is it just a fad? What do you think? A trend. So you think it's coming, it's happening, and it's going to stick around. Great. Anybody think it's a fad? Yeah. Why do you think it's a fad?
I don't think that's anything to do.
Yeah. The human shape, our way of working, has value to us. We've built a human world, like we have steps. To climb steps is not easy for most robots. So in that case, a humanoid robot in a human world might be valuable. Okay? But if I want to move a 40-pound package from here, let's just say from here to here, all I have to do is have enough inertia to slide that package forward. But if I'm a humanoid robot, I have to pick it up, I have to hold that weight for the entire distance plus the inertia to move it, and then set it back down. That was way less efficient than some wheels, right? And so we want to make sure we're choosing the right form factor for that. But let's just kind of see where the rest of the industry is on this. I think the humanoid robots are currently a fad, but maybe in the future they are a real trend. Okay? But what we are seeing right now is this concept of the service robot, a robot that can go and bring you a plate. So right here in Chapel Hill and the Sheridan, you can have your food brought to you by a robot. Okay? The Mayo Clinic is doing some really interesting things of bringing the trays to their patients directly to them without having any delays. And they're able to do that with robotic assistance. So let me show you where the state of the robots are here with Figure One. They just signed a $350 million investment. They're very successful right now. And so this was as of March of 2024, so it's almost a year old at this point.
Hey, Figure One, what do you see right now?
I see a red apple on a plate in the center of the table, a drying rack with cups and a plate, and you standing nearby with your hand on the table.
Great, can I have something to eat?
Sure thing.
Great. Can you explain why you did what you just did while you pick up this trash?
On it. So I gave you the apple because it's the only edible item I could provide you with from the table.
Great. So based on the scene right now, where do you think the dishes in front of you go next?
The dishes on the table, like that plate and cup, are likely to go into the drying rack next.
Great. Can you put them in?
Of course.
All right. So how do you think you did?
I think I did pretty well. The apple found its new owner, the trash is gone, and the tableware is right where it belongs.
I agree. Thanks, Figure One.
So what'd you see there? What'd you think? Yeah. Yeah, and on it, you know? Yeah, so the language mimicking of the human voice was really strong. Okay. What else? Did it feel creepy at all? Why do you think it felt a little creepy? Yeah, so it's not quite there, right? What I also saw there is a disconnect between the audio and the visual. The audio was very human-like. The visual was very machine-like. I actually think it would not have felt as creepy if they would have just used an actual machine-like voice to do the exact same thing. Okay? But the voice has gotten a lot easier to do than the visual. The other thing I wanted to talk about what we saw there was it was able to use computer vision to see and understand its environment. It was also able to make decisions about what to do based on inputs that were coming from the human. But then it was also able to evaluate how good of a job it did. Okay? And it probably evaluated that in a mathematical way that then translated that into language that humans would understand. I think that is a major step in what we're able to do now. And I think you're seeing that. Now, will that be in a humanoid form? Maybe, maybe not. Okay. But I do think we're seeing this level of intelligence of being able to assess things is a really important thing that we're learning from the robots. Which brings us to where I actually think the robots are today and they're most valuable is the task-oriented robot. So not trying to build the humanoid robot that can do everything, but to do things that can do things really good. For example, the best one out there is the Roomba. Who in here has a vacuum cleaning robot in their house? Okay, just 1, 2. All right, 3. Okay, we do have some. It can clean a house. Can it clean your whole house? No. It can sweep the floor, vacuum the floor, right? Some of them can mop now, but they're basically single task oriented. We didn't try, or Roomba did not try to build something that could also clean your bathrooms and mop the floor and all these extra things. They wanted to do one thing and do it well. And they found a great product fit for doing that. There were a lot of people that wanted that. We see the same thing. For example, what you're seeing here is the spray bot. And the spray bot leverages a lot of technology that we've been working on to solve a very specific problem, which is spraying and painting metal parts. Okay, so Bargo is a computer vision engineer and our team who's worked a lot on this project, and he's going to explain not only the task itself it's doing, but how it works and what's going on in the background from the AI perspective.
Yeah, so I would like to bring everyone's attention to our friend Jack. Jack is in a box. This is our paint robot. So we do have robotics in the name, but at our core, we're like computer vision is what makes us really work. So here we have a demo set up for you to see how our computer system actually works. So on the left side, you can see regular object detection. I'm sorry if I'm blocking anybody. But you can see how it detects different parts. So it knows these small parts are part B. This will be a conduit body. So it does regular object detection in 2D space. It knows where the X, Y, like on a plane, the coordinates are. We leverage a depth sensor on our camera. So we use a Intel RealSense camera. It uses a time of flight LiDAR sensor. So now we can use that data and combine it with our 2D bounding boxes to create, on the right side, bounding cubes. So now it knows that Z coordinate of where the parts are. So we have its XYZ coordinates, and we can manipulate the point cloud data to actually know the shape of the objects as well. So if I run the demo, when it runs, it'll go through all the parts, and then once it gets to this side of the tray, it'll actually like go over the contours of the part based on the shape that it's detected using the depth sensor.
So we have a 30-second delay on it, so it's looking and seeing the parts, and then it will actually kick off. But it does it very quickly. We just put a little delay in here for safety and discussions. So.
Yes, exactly.
Well, it actually does that really quickly. It was evaluating it every second, but the 30 seconds was literally for demo. Like we just put it in.
So it'll take like, you can make it like 30 frames a second, and it'll do like, and it'll process it at that speed as well.
So one of our clients saw a paint savings of over 70%. They used 70% less paint while doing this versus when a human was doing it. So they were able to see how much more efficient the robot was than when the previous ways they've been doing it. Yes.
So how does it determine path planned out? Like detect all the objects to make a path, and then the bot follows that path. Like just every second.
Yeah, so for this demo right here, we have path planned it. So we told it to move the rail like this much based on this tray. But you can also have it do a movement like, okay, there's a part you detected in this XYZ location. If you see like part B, go there and then do like one specific motion. I also do have this little contraption right here to show some cool new technology that we're working on. So has anyone here heard of a diffusion policy? Diffusion policy? No? So basically it's this new AI technique used mostly in robotics. Basically it's a way to teach how a robot should move based on watching examples of it. So you see there's a GoPro on this. This is a gripper, so when I press it, it opens and closes the jaws. So what I do is I can like move, I can take a video of myself moving around a part, pressing a gripper to pick it up, placing it somewhere, and I take a bunch of videos of that. It turns into training data for the robot. So now the camera on the robot will mimic exactly what I have told it in its training data. So in that sense, we wouldn't have to explicitly path plan it. It would just know from watching examples in the training data.
So a lot of the things we do is we're like, let's say we're picking up a bunch of these metal parts out of a bin. Okay. Well, that part could be like this, like that, whatever. Well, if you just have a human who has years of experience picking it up, there's lots of different ways they could pick it up. And so no matter what direction it would lay, I know how to pick this up. Now I've got, do it 100 times. Now we know every single orientation we might be able to do. So that's how computer vision has really helped us a lot. So cool. Thank you, sir. Can I take your mic?
Yes, for sure.
For battery. This is for our live feed. So questions about the computer vision and what's going on there? So the idea for us is this SprayBot is one use case. It's easy to set up. It ships out to you in a pallet just like this, and you can raise it. We basically built this in about 45 minutes today. So it's a pretty straightforward, easy to implement concept. Which is a form of soft robotics. So, or sometimes we say flexible automation. Okay. Traditionally, and like what we see with, if you were to think about going to Krispy Kreme has hard or fixed automation. They are set in a specific place. It happens over and over. It's bolted to the floor. It's welded to a bunch of different rollers, and that's the system that we have. But then now with AI, we're able to do a lot more soft automation. So we can move things in and out. We can have variable heights. We can adjust to the environment as things come on. So a fixed system we want to use for high volume. When it's the same thing over and over, you're going to do the same thing. You know the thing, you know the process. There's a great place for that. And that's what you think about building an automobile. Okay, cars, the same thing over and over. It's already been designed and fixed. But a lot of times we want to be able to evolve and change it over time. Products can have iterations to them. So our automation for building those products need to be iterative. And that's where flexible automation comes in. What's nice about it is it's an evolving process that it lets us to grow our company or grow your company while you're solving a problem, and then you make it better, you fixed it. Well, you don't have to wait for months to redo your factory. You go in, reprogram it, and move forward. Okay? And so having tools like this can be really important. We also love to talk about modular cell design. So Charles and I were talking earlier about kind of how you build out in automated systems, and typically you have these cells and you build them out, and a lot of times they're fixed. But if we can build them in a way that's flexible, that is strong and sturdy, but also easily movable, and think of them like Legos, and we can kind of build these puzzle pieces together, then that lets the company grow as your products grow and change. So the question I love to ask business owners, people who are working in these types of environments, is what are you doing 1,000 times that you wish you didn't have to think about? What's the thing that just, it's got to happen, it's got to be over and over again? You know, that might be, in this case, it's spraying parts that are the same all day, every day. For others, it's, we have this little part that has to be welded on this big part, and we got to do that 1,000 times. Okay, well then maybe that's a good spot for robotics. It also may be something that I'm not thinking about. It doesn't have to be physical. Maybe there's things out there that you're thinking about that, wow, we have to process this form every day 1,000 times a week, right? And maybe that's a place for automation. And so how do we do this? How do we find different places for all of these different tasks? The most common ones that we see and that we're able to deploy very quickly is welding, painting, sanding. The idea of doing something over and over again that's a repetitive motion. Okay? But we can add vision to that. So if you want to sand a cylinder, we can press and understand the torque values and things and do that. So there's a lot of smart things we can do that makes it a little bit more flexible and not have to be the exact same part every time. We also see great value in how we pick things up, as I was showing you earlier. We say machine tending. So a lot of times a part needs to be picked out of a bin and placed on an automatic welder. We can take that and do that. And so that's something that robots are really good at. And then also packaging. If you think about packaging, it's the same repetitive process over and over. One of our clients, their people had to pick up a tube, put something in, and do this over and over again. Like that is just a horrible ergonomic action to do over and over again. But a robot, as you saw out there, that hand out there, it can do that over and over and not be a problem, right? And so we want to choose the right tool to help make you more efficient. So just like we were talking about how to evaluate AI systems, I think you also need to think about how do we evaluate robotics or automation systems. So one thing I would tell you is you need to be able to solve the problem first before you try to automate solving the problem. Okay? Don't build the factory until you've built the product first, right? So know that. That's the thing that sometimes people try to jump into. Once you have the problem solved, you are ready to automate it. Start with just one piece of it. Okay? Maybe it's just the welding. Maybe it's two-piece assembly. Maybe it's the painting. Whatever it is, start with one with a vision for the future of all of the others. But really, you don't have to automate your entire system from the beginning. Great part about it, you put this on a pallet jack and you move it, and then you add another pallet jack group for it. You add another pallet to it. And that way you can build and grow over time. It also helps you with capital. It also helps you to learn what you're good at automating and not, and working from there. And then also, simple is best. If you can find a mechanical, simple way to do it, then do it that way. Okay? Not everything has to be a robotic arm. The robotic arm is really good at things, but sometimes a simple ramp might be all you need, right? So we want to keep it as simple as possible. So I've shown you the spray bot and talked about it. The example, we were going to have Justin to join us. One of our clients is the owner of L&M Signs. And he makes the signs that you see in these big buildings. They're called wayfinding signs. They're the metal signs that say like Suite 300, whatever. And then his challenge was, it was a high profile building in Manhattan. And something that was painted one day and then painted 3 weeks before, those two signs might be next to each other. And they have to look perfect. And the finishes aren't the same. It's not going to work. So the challenge he came to us with, he's like, I don't care how fast it is. I care that it looks great. I want it to be perfect. I want every finish, every sign that comes out of our shop to look exactly the same. And that's what we were able to do. By doing that, it created great efficiencies. It created cost savings and all these other things. And the robotics really helped that. But that wasn't his main goal. Those were all extras that got added on. So it's been a great place for him. If you're running a company and you're doing some things, we have a automation analysis tool. So Andreas worked really hard on this. He has a history in working and making factories more efficient. And we've worked through a tool that you can go through, and it just walks you through asking some questions about what we can help with automating for. Okay. And so as you go through that, you can save it as a PDF. You can also talk to us, and we can help you kind of get to the end of that of what you see. Okay. But I've talked a lot, and I know you may have questions about kind of things that you're working on, or ways that we may be able to help, or just things about AI, and I'm happy to answer those. So what questions do you have for me?
I have some questions for our digital.
Okay.
What's one of the most surprising capabilities in developing that you think could be solved with robotics?
Ooh, that's good. What have we seen this week? Working in really cold environments. So in pharmaceuticals, certain samples need to be kept at -40 degrees. And so you may not realize it, but humans are not very good with parka and big thick gloves and all of those things. But a robot doesn't care how cold it is, as long as you get the right robot, right? And so I think being able to work in environments that humans don't want to work in, or don't enjoy working in, or even not best suited for, is kind of an interesting thing. So I think that's a really interesting answer to the question. I'll see if I can think of another. Did you have more questions from the group?
Yeah.
Oh, really? Okay. Go ahead.
Yeah.
Okay. So big companies were early on, the big automakers. Those were the earliest on, right? Then you had still large companies that were able to do a big capital investment, big time money, big spends on big expensive robots. But now what we're seeing is the cost of robot is coming down. We also have the ability to do robotics as a service. So you might have heard of SaaS software, like software as a service, that you pay a monthly subscription fee. We do that with robots, which allow small business owners to get in without having the big upfront cost. And so they're able to do a monthly fee rather than pay a lot of money upfront. And so that's enabled more and more smaller businesses to get there. And so that's been exciting and helpful to a lot of kind of people in our area to be able to grow and kind of change the way they do things and to see more efficient, to be able to compete with some of the growing larger corporations.
I have another really good one for you. I'm sure you guys have some questions as well, but are there any things that you think should not be automated?
Things that should not be automated. Well, part of it is you have an expense to automation, right? And so certain things, if you're not doing enough volume, it's probably not worth automating on. So there's just a math calculation to that. I kind of feel like at this point, like if you're doing it over and over again and you figured out how to solve the problem initially, there's probably a way to do it a little bit more efficiently. So I wouldn't say there's something that should never be automated. One time I was giving a speech and the keynote before me a couple of hours earlier, I said, if she called me and said she wants a bunch of robots, I'd tell her that was a horrible idea. And guess what? 2 days later, she emails me and she's like, I'm going to prove you wrong. Okay. And now she's a client. So I don't want to say that there's nothing that you can't automate. But I think you do want to choose well about, okay, let's go take on the things that we have a known process, we have a known solution, and then try to automate those first before you take on some of the bigger challenges. Any questions here in the room before I go back? Yes.
I'm wondering, those LiDAR cameras, like the data you're getting,
Yeah, we were actually talking about that today in the as we were sitting here. There's a lot of artifacting. If to see what he's talking about here, we got a lot of things happening. These are jumping around a little bit more. This is not an ideal environment, and we would probably not go into production with that type of artifacting there. So what we do is like study to understand what it is. I think what we're seeing is a lot of reflecting of this particular. We got two different types of lights here. I think we're getting some weird reflections on this, and that's causing what you're seeing there. But that's something we would need to minimize either by filtering through software or even just controlling the environment and making sure we deal with those things. One of the things we can do is build synthetic data. So if you think about, let's say we have 100 images to train something on a model. We can take those and say, well, now take those same images and apply fluorescent lighting to them, or apply, in our case, we have a factory that's a warehouse that opens a big garage door throughout the day. Well, that changes the lighting conditions. So we have to be able to be prepared for that. And so we can use synthetic data to help train on that as well. So yeah, you're right. There's a lot of artifacting there that we would need to deal with before we go into production. Good note there. Yeah.
one of the examples talk about how there's some other value saving money. You highlight how, for example, higher quality. Is there a particular reason you highlight that the first priority is automation?
I think it's more that most people expect that efficiency is going to be the best. We actually, for most of our clients, we want to target being able to do it at the same speed of a human on a standard shift. And then the efficiency comes in the fact that they can go multiple shifts, or they can go for significant time without stopping and those types of things. And so you see that efficiency. So when I say it, it's not all about efficiency. It's more because that's the standard answer for robots, right? That's always been the case. What we want to do is not only make it efficient, we also want to make it high quality and great work. Yeah, Tyler? Yeah. The one we're using right now is from Intel. It's the Intel RealSense camera. They actually have spun that into its own company, which is a great thing for the future of robotics, because it means it's going to be supported and grow in the use cases. There's another type of camera that we're looking at that is called a structured light camera, and we've done some experiments with that we think will give us even higher quality. And so we may switch to that. It just kind of depends on the use case of what our client needs, basis on the camera that we need, then we choose to use. So we can use, in some ways where we can be camera agnostic as long as it's a depth camera. but is, you know, we'll choose the right one for that particular environment. Other outside questions from the digital audience? Yeah. Well, interestingly, we have a group here who's a bunch of high schoolers we're glad to have here who have some great technical questions. I think one of the things is kind of the math and science side of things, the engineering. So we have mechanical engineering, electrical engineering, software engineering. All of these are what it takes to make a good robotics team, and so that's what we have in our field. But it's not just that, because we also want to study how humans interact with computers. So human-computer interaction and the psychology of that. I know we have a psychology person here in the room. One of my grad students is working on how would people like to engage with a humanoid hand? Would they rather fist bump, shake its hand, or high five? I don't know. I have a theory, but what we're going to do is let the research tell us, right? So there's a lot of fields that can come and intersect with robotics. But the majority of ones that we're using kind of in our world that we're doing every day is mechanical, electrical, and software. Other questions? You got another one, Tony?
Yeah.
Okay, go ahead.
Are there any recent breakthroughs that you think folks do
So I think it's important that we also look at some of the interesting things with DeepSeek. So if you know, DeepSeek came out about 3 or 4 weeks ago now from China. I would not encourage you to put. Let me just go ahead and say, I would not put that on your phone. Don't download the app and put that on your phone. I've used it in the browser. We've tested some things. There are sensor data. There's a lot of things going on there that are inherent in where it was produced and how it was produced. Okay. The value of something like DeepSeek is it allows small businesses to be able to do their own large language models and implement it at a cost significantly lower than what OpenAI, Gemini, and all these other systems are. Okay. But there's also trade-offs to that. And so you want to think through that. So I think the DeepSeek thing is really interesting. Now, we saw a moment where basically the stock market kind of totally reacted to what came out with DeepSeek. And the reason is because there was so much influence and so much capital in NVIDIA. And NVIDIA is making all these chips. And the question was, well, if this is so much more efficient, do we need all these chips? Well, the answer is still yes. We still need all of these chips. So some of the things that came out with DeepSeek and some of the other competitors that have come out have implied that they didn't need so much learning, and maybe they are a little bit more efficient. I think they did come up with some really interesting algorithms to do things a little differently, but they were still trained on models that needed those same types of deep learning graphical chips. And so NVIDIA still got a place to be. And so I think that's still a valuable place. But to the original question of like, what are some of the insights there? I think DeepSeek was something that totally made everybody wonder what's out there, but I used it for a couple of times just more as a test, and then I went right back to my other tools. Okay, and so I think we'll have to kind of see how those things play out. Some other interesting things about the humanoid robots. There's a lot going on with humanoid robots. I do think we're going to see that take place where, you know, in your careers, you're going to have humanoid robots working alongside you in certain capacities, maybe in household chore type solutions. But I don't think it's going to happen in the next 10 years. Okay. And I'm going to go ahead and say that. Like, I think we are a long way away from that actually being the case. What we saw at Elon Musk's party where he showed these things off, a lot of the things were AI, but a lot of the things were human remote controlled. And so we're just not quite there. And so is it 10 years? That's my estimate, but I think it's one of those things that there's a lot of cool things happening there, but it's going to take some time to actually get there and make it usable. Yes, sir.
Looks like I saw there, and there's a lot of the stuff they'll do with like most
Mm-hmm.
Have you done any other kind of like some other areas?
Yeah. Right. The majority of our work is with the robotic arms and rails that move back and forth, but we can also do AMRs, so automatic rovers, like moving. Forget what does AMR stand for? Thank you, autonomous mobile robot. Thank you. And so being able to move through an environment. But you can take that, you can put an arm on top of it, you put vision on top of those things. And so I know a lot of the like robotics clubs and things do so much more with rovers. We actually do so much more with task-oriented bots that are in specific locations and typically in a cell design. But it doesn't mean that like they all have value. It's just a matter of which clients we end up with. Tony?
We got one more good one from the left. What happens to the
So anytime someone's talking about the ROI of robots, they're typically talking about how they're going to replace people. Okay, and I think we as a society have to think about what happens when we have autonomous vehicles replacing so many drivers. Okay, what are we going to do in certain factories that are going to be where we have warehouses that are trying to become dark warehouses that are completely. So there's some big society things. But there's also some really interesting things that we've seen. For example, one of our clients with us talking about the paint bot, Geo is his painter, and he hated painting these signs. He likes doing much more creative things. And so, so Justin, his boss, has moved him to do more creative work, and he's found new business opportunities by having his master painter do things besides just painting a sign over and over again. And so that's one of the things that we're seeing. We're also seeing some interesting training programs from a lot of the factories where they'll take a group of people, teach them how to maintain and train the bots, and use them as kind of retooling and retraining so that they can manage it. But I don't want to overstate that because that's typically like a 5-to-1 relationship, right? That you may, not have 5 jobs here. You're replacing them with one person doing that. So as we look to kind of like the broader implications of this, I think we have to see what are we going to do as a society to retrain and make sure that people can move into this new economy in the same way that we moved from the industrial age to the internet age to all of these different things. We've got to be able to respond to that. Natalie?
When you with robots, you want to find solutions and then automate it. But it seems like when you're finding the solutions, it kind of maximizes the way that it's done. Like with machine learning, you see so many different ways to do it that the robot can kind of figure out what's best. Like the painting, you said it saves like 70%. I think that they're also just part of it that humans didn't actually get to the part where they learned how to maximize efficiency or waste, and the robot just the constant having to deciding to get a robot just kind of pushed into that. So is it more just a human error or?
That's a great question, right? So some of those things we'll not know, but I would say that kind of one of the main things is that there's certain things that machines are really good in, and that's precision, right? What's the repeatability on that particular arm? Do you remember? Okay, 0.01 millimeter, meaning you can hit the same spot exactly every single time. And there's no human that can hit that same level of precision, right? It's just not possible for us to do that exact spot over and over. We're talking about like a pencil touching a dot the size of that pencil dot again and again and again. So that's something our machine's really good at. In the particular case with the painting, we were able to hit the edges exactly like they wanted. No extra strokes that weren't necessary because we knew that this one overlapped that one at that exact place we wanted to. We didn't have to have an extra overlaying stroke. And so those types of things were just, the machine could do it differently than the human. So sometimes people say, oh, I want to train it with a human, like we were talking about this, right? We can train it with a human. Sometimes we might actually want to just use math, right? We want to use the trajectory and we do it very strategically so it's more efficient in that case, right? There are certain things that I think machines are just not going to be as creative, right? There are certain things as far as the precision over and over again that machines are better at. Yeah, so it's a great question. So we had, I would say we had a client who had a downtime yesterday. They had a power failure. Things came back up, didn't come back up the way it was supposed to. Okay, it's been running for 6 months nonstop without fail. All of a sudden, it quit working. Okay, so machines break, right? Things happen. We had to deal with it. Okay, but the fact that it ran for 6 months nonstop without a problem, which is a really great task, right? So things we have to be careful with. These things have movements. They have vibrations. So you got to plan for that, right? Like you can't just use a regular bolt. You got to make sure that you're tightening them in ways with particular washers and things so they don't shake and rattle around when they're moving, right? There's certain things we have to think about from an engineering perspective to do that. Then you're also going to need support over time. So with our clients, we ask them to sign a support contract specifically so that we can say, we want to make sure this works for you over and over again. Or if they're doing robotics as a service, that's built into the system. And so we will support and maintain it, right? So we want to make sure that we, kind of follow and keep and maintain those. In companies that are like bigger manufacturing environments, typically they train somebody locally who has a checklist of things to do that they will go and follow up and make sure that this checklist, all these bolts have been checked, all of the connections are good, all of those things, just to make sure that it hasn't changed over time. Yeah.
How precise is that what you said, like moving 1.5
Yeah. 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 So one of those things that this thing has the life of, if it was working an 8-hour shift for normal, it'll go for 3 years. Okay. 3 years without breaking of the thing. So it should be precise through that the whole thing. Now, if I was doing something in say pharmaceuticals, or I was doing something where precision really mattered and I want to make to it, then I need to make sure I have protocols in place to check that every month. Right. So I would just, have a process, hit the check, see does it hit the spot, good, move on. Right. I would put those in place. And so it really depends on the use case. What does that particular company need? And then building a protocol that works for that company. But a lot of times people don't necessarily need that same level of precision, right? So it just depends. Yeah.
Another from the live stream. How long does it take to implement?
Yeah. So this particular spray bot, kind of as is, then that basic model starts for robotics as a service about $2,500 a month. Okay. So it's a pretty affordable use case right there. Some of our clients need much more implementation. They need bigger rails or very specific implementations, and we do those. And so typically we say about 6 to 8 weeks with delivery of the products and everything. We can get kind of a basic project. If it's bigger, maybe it's 12 or 16 weeks. Okay, so it's a matter of weeks, not years or months or years to get up and running with automation. Yeah, Nella?
I know we were talking earlier about
Mhm.
base spot of that style.
Yeah, great question. So first of all, there's a software piece to it. So we've developed software for this computer vision that allows us to be part agnostic or job agnostic. We can do all kinds of different parts and things. And so that's the reason we're able to get going very quickly, is because we're not reprogramming. So if you think about how your group is working for the challenges that you guys get in the robotics program, each challenge is different and you kind of have to start from scratch. The way our software works is we're going to start with our base software and then just make adjustments to it, right? And that's really the kind of long-term piece to that. So software is key. And then we also leverage a specific kind of set of components that make it best. We kind of use 2 different rails and we stick to those 2 brands of rail. We have a specific robot that we try to use, a particular arm like that, that we use over and over again. But that being said, if someone comes and says, oh, I need one that can lift a whole lot more and be more for welding and larger, say it was an aircraft, obviously that one wouldn't work. So we would go and find the right robot to do it, but leverage the same software. So, great question. Yes, ma'am. Mm.
General, the ideas around who's the robot brain.
Yeah, I think that is a really important thing to ask. We had a really exciting opportunity that came up around space junk. Okay, now our company couldn't survive and last long enough for SpaceX Space Force, whatever, to work out, and so we said no to that one. Not because we didn't want to be involved with with the government agency or anything, because it was more of a business perspective, right? But then we also have seen where we have clients who want us to do things that maybe I morally would disagree with. Okay, there's no way we're going to step into that role, right? If I have a moral problem with it, I think that we're not going to do that. Okay, we have a board, and I think we would have the discussions among that board if that comes up. But I think let me get to a little bit more of the ethics questions, like more hands-on, like tangible things. We worked on a project during COVID that did mask detection, and it would basically detect, did you have your mask on or off? And basically, even if you had it right below your nose, we could tell if you were compliant or not. And that was used for scientific purposes. It was used to encourage people to wear masks. The question is what was that data trained on? Where did it come from? Well, it actually came from 2 or 3 years before, when swine flu was a big deal in Asia, and it was only trained on Asian faces, okay? Specifically Korean faces. And so how do we deal with that, right? What would happen when darker skin faces are there and different ethnicities are there? What are we going to do with that? And so, there was a stop. Let's think about this. Now let's supplement that data and make sure we have a representation of the demographic of where we're going. We actually didn't try to do the demographics for all of America. We actually tried to do the demographics for the places that it was going to be put into, right? And so thinking about how people are going to use it and then doing it. The other key part is messaging and letting people to understand like what you're actually doing. So because we were detecting if you were in a mask, people thought we were doing facial recognition. We were not, but there was a fear of that, right? And so the ethics of that is, let's make sure we're very clear about what we're doing and how we're doing it, and make people to understand that, rather than just, oh, we'll just assume they're going to be okay with it. Time for one more question. You ready? Yeah, right.
You were going into college. You were one of these
Hypothetically, if someone was going to college, yeah.
If you were in like a software or mechanical lens, something that might end up in a place like this or somewhere similar, what are the majors or areas that you might avoid because they might be automated?
Oh, so you reversed the question. I thought you wanted me to relax. That is a really hard thing. So I have a 14-year-old, and I think about this a lot. Like, what careers are my kids going to be going into that are not going to be replaced by robots? Right? In the immediate future, I think there is a need for people who can do and work with these AI technologies. So there is going to be plenty of engineering jobs who can write and build these algorithms. Okay. Where there's not going to be jobs is traditionally like web design and the kind of things that have become commoditized, something we've solved over and over again, and then we're able to do that. If we think about things that you're less likely to be involved, like, you ever heard the concept of where do you make money in a gold rush? Pickaxe and shovels. Okay. So make the tools of where people are going. If AI is going to be the next thing, then you got to be able to make the tools in AI, right? So I think that's a key thing to do. I also think there's a piece for problem solving. So AI is great for responding to what we need and giving back data. AI has not been able to sit down where I have a client who gives me a crazy idea that you wouldn't believe some of the ideas people come to us with. And then you just have to have an epiphany that one day solves that problem. I don't think AI is doing that. Now, we'll leverage AI to help us get to that solution and help us to actually put it in place. But the actual problem solving piece, I think, is really important. So is there a specific major for problem solving? Not really. Okay. But I think understanding design, good design, architectural design, engineering, mechanical design, those types of things are still going to be really valuable, but you're going to use AI tools to do it, right? Like, my dad went to architecture school and he learned how to draw on a drafting table. He hasn't used a drafting table in 25, 30 years, right? But it didn't change the fact that he still needed to have a different viewpoint of how to design that office, how to design that building, right? So look for the things where you're going to be adding value, where you're going to be doing something that only a human can do, right? And I think problem solving is one of those. Please.
When you and see grads, help people. Probably the greatest thing I learned. That kind of ties on to the degrees that he's talking about. I see it every day. Those people who really do those things.
Yeah, that's a great point. I'll give you a story from graduation day. So this is several years ago. So it was before ChatGPT. I go up and see a student who's graduated, and she introduces me to her parents, and great moment. And she says, "Yeah, I feel like I got a degree in Googling." Okay. Now she was saying that as a compliment to me. Her parents thought they just paid $100,000 for her to get a degree in Googling. What I saw was she learned how to learn, right? She knew that there are certain things she's got to go out and get, and she's like, "I learned how to Google." She didn't really know how to Google, but but essentially she learned how to problem solve, right? And so I think you want a place where you're going to a school that's not, or a program that's not just giving you data, but they're saying, we want you to work on these real world problems, working with real world clients, solving. One of my students right now are working for like very specific clients to solve a problem for them, and then give that back to the client, right? That's what the most valuable thing they can do is right now. Anything else? All right. So, well, thank you all so much for coming. If I can be helpful, especially to this generation here, if we can be helpful, I've got engineers here. You're welcome to meet. There's 2 in the back there. So feel free to answer and ask questions. But if I can be helpful, let me know. And thank you for your time. And thanks for coming.